question 12, part B of Seoul National University's Mathematics Aptitude exam that was held in 16th of February 2016. The reason I chose this question is because this is at first glance it may look difficult, but if you actually do the maths, it's not that bad. So let's have a look. There are 3 points given. Point O, which is 0, 0, point A, which is cosine squared of t, 0, and point B, 0, sine squared t. OAB is a triangle, and the area of the triangle has a rate of change of 0 at time t, at the value t. And from that value t, from those value of t's, the smallest positive value, real number, let's call that t0. At that point, what is this sum? So I think we have to, firstly, our first instinct is to find out t, right? Because we have to find t0, right? So it's basically saying that in a graph, on a coordinate system, point O, and then 0, cosine squared of t, 0 would be somewhere over here, right? Because that is point A, and B would be somewhere over here, 0, sine squared t. And these points are moving at some rate as a function of t. And the triangle that is made from OAB, this area, let's call this area A, is also going to be a function of t, right? Because that is the definition of the triangle itself, because the points A and B are moving. So let's find out A of t. A of t, well, is base times height over 2. The base, which is cosine squared of t, times height, which is sine squared of t, over 2, right? So we can rewrite this in many ways. Should I write this in any different way? I don't really think so. I'll write this actually as 1 over 2 times sine squared of t minus sine to the 4th of t, because cosine squared of t can be written as, because we know that this cosine squared of t equals 1 minus sine squared of t. If we multiply that out, that's sine squared of t minus sine to the 4 of t. I think you can use the double angle formula, double angle approach here as well, but yeah, I'll just do it this way. That is the area as a function of t. So we're saying there is some t value where the rate of change of the area is 0. So there's some place where dA of t dt, which is half times 2 times sine of t times cosine of t, minus 4 sine cubed of t times cosine of t. And there's some t value where this is equal to 0. I think we can do some factoring out here. Because it's multiplied by half, this is sine of t times cosine of t minus 2 sine cubed of t cosine of t which is 0. And we can get sine t, cosine of t outside the brackets, and factor out as 1 minus 2 sine squared of t, right? Which is equal to 0. So we can see that there are several t values. This is 0 when, firstly, this expression can only be 0 when sine of t equals 0, when cosine of t equals 0, or when 1 minus 2 sine squared t equals 0. So sine t equals 0 and we want t values which are positive and small, right? So sine t is 0 when t equals pi, 2 pi, or 3 pi, but we always want the smallest one and positive one, and which is greater than 0. So this sine t equals 0 when t equals pi. Cosine of t equals 0 when t equals pi over 2. That is smaller than pi, so this might be the answer. And 1 minus 2 sine squared t equals 0 when 2 sine squared of t equals 1 and sine squared t equals 1/2. And therefore sine of t equals plus minus 1 over root 2. And we know that that for positive 1 over root 2, t equals pi over 4, right? It's either that or minus pi over 4, but t must be positive, so we're only taking the positive smallest one. So we got 3 t values, t equals pi over 2, or pi over 4. We want the smallest one, therefore we can conclude, hence, t sub 0 equals pi over 4. Now, coming back to the question, we have to find this sum now. So we can now write it as the sum of from n equals 0 to n equals infinity of the absolute value of cosine of n times t sub 0, which is pi over 4, over 2 absolute value to the nth power. Now this might look very difficult at first, but if we try writing the sum out, maybe that might make our lives easier. This is equal to, when n is 0, that is cosine of 0 over 2 absolute value to the 0, plus when n equals 1, that is cosine of pi over 4 over 2 absolute value of 1, plus absolute value when n equals 2, that will be cosine of pi 2, I'll write it as 2 times pi over 4, 2 times pi over 4, oh no, I'll just write it as pi over 2 over 2 absolute value of 2, plus absolute value of cosine of when n equals 3, that's 3 pi over 4 cubed, and when it's 5, let's go until 4, plus cosine of when it's 4, that's cosine of pi over 2 to the 4, and let's do 1 for luck. The fifth term is cosine of 5 pi over 4 over 2 to the 5, and so on and so forth as an infinite series. So let's have a look here. If we simplify this or generalize this, we get this equals to 1 plus cosine of pi over 4 is root 2 over 2. So 1 over root 2 divided by 2. And then we get cosine pi over 2, which is 0, and so on. So if we look at this term, cosine of pi over 4 is root, so we get root 2, I'll write it as 1 over 2 root 2 to the 1 power. I'll write the power. Cosine of pi over 2 equals 0, plus 0, plus cosine of 3 pi over 4, well, that is cosine of minus pi over 4, but we still have the absolute value. So that is actually equal, the insides are equal to cosine of pi over 4. Notice that. So we can write this as 1 over 2 root 2 cubed as well. The next term we have cosine of pi, which is minus 1, but minus 1 absolute value is 1, so we get it as a half, right? So that's 1 over 2 to the 4. The fifth power, we get 5 pi over 4, which again is pi plus pi over 4, which we'll get minus 1 over 2 root 2, minus 1 over root 2. So we'll get absolute value of, so root 2 to the power of 5, and so on. Notice that there is a pattern. Well, firstly, we can see the 1 over 2 root 2's appear. We have the 1 over 2 root 2's appear when there is a, from the simplified version, a over 4. For example, 3 pi over 4, 5 pi over 4, 3 pi over 4, 7 pi over 4. The next would be 9 pi over 4. So there we have a sequence that we should know how to calculate. And then we have the cosine of integer multiples of pi, cosine of firstly 0 pi, and then we have cosine of 1 pi, and then cosine of, we'll have 2 pi somewhere when n equals 8, and that is the 1 over 2 values, right? 1 over 2 plus 1, so 1 over 2 to the 0, which is 1, plus 1 over 2 to the 4, and then we'll get 1 over 2 to the 8 when n equals 8, and so on and so forth. And we'll get 0 as our things when the inside of the, for terms where the insides of the cosines are integer multiples of pi over 2. For example, pi over 2, that would be 0, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on and so forth. So basically, what I'm saying here is we can, for this infinite series, we can simplify it. We can divide it into 2 parts. Well, that is, we can divide it into the, well, we can firstly ignore the zeros. And then we can look at the 1 over 2 to the 4, 1 over 2 to the 8, right? So that is 1 plus 1 over 2 to the 4 plus 1 over 2 to the 8 plus 1 over 2 to the 16, because it comes in, sorry, not 16, 12, because it always comes in 4s and infinite series of that. Plus, we have the 1 over 2 root 2 sequences, which is 1 over 2 root 2 plus 1 over 2 root 2 squared. No, cubed actually, because it comes every 2 times. Plus 1 over 2 root 2 to the 5, and so on and so forth. So we can write this in terms of another sum. So we can decompose the original sigma notation into 2. We can write this as n equals 0 to n equals infinity of 1/2 of 4n, right? When n equals 0, that is 1/2 to the 0, which is 1. N equals 1, it's to the 4 when it's 2, and so on and so forth. Plus the sum as n equals 0 to infinity of 1 over 2 root 2 times 2n plus 1, right? Because it's only in the odd indices where it occur, and because when n equals 0, it should be 1. We can write the sum in this format. So obviously this is a geometric, both are geometric sequences where, the geometric series where the common ratio exists, and for a sum to infinity of a geometric sequence, we know that S8 equals a over 1 minus r, where a is the first term of the sequence. So the addition of 1 plus 1 over 2 to the 4 plus 1 over 2 to the 8 would be, the sum to infinity would be 1, which is the first term, over 1 minus whatever the r value is, which is 1 over 2 to the 4, right? So we'll write, 1 over 2 to the 4, which is r, plus the sum to the infinity of the second geometric sequence would be 1 over 2 root 2, the first term, divided by 1 minus r, which is, from this we can see, is 1 over 2 root 2 squared, right? So let's clean this up. This can be written as 1 over 1 minus 1 over 16, and this can be written as 1 over 2 root 2 divided by 1 minus 2 root 2 squared is 1 over 8, right? So this can be written as, I'll write it on the side, 1 over 1 minus 16 is 15 over 16, plus 1 over 2 root 2 divided by 1 minus 1 over 8 is 7 over 8, right? So we can rewrite this as, the whole sum would be 16 over 15 plus 8 over 14 root 2. And obviously this can be simplified down as to 16 over 15 plus 2 root 2 over 4 root 2, actually. No, 2 root 2 is correct, because it's divided by 4, we get 4 over 7 root 2, but this can be, we can use the surds as, and write as 2 root 2 over 7. So that is the final answer as a numerical value of that sigma notation. Thank you very much.